Hi there, Turgeon here, bringing you physics from afar. Here are some hints about the Measuring Sound Lab. As you can see, we have the lab sheet here. I'm emphasizing that in this video you're going to need to listen, and also I'm emphasizing it's not about taking my words and writing them in here. I'm going to give you hints, so you're going to have to really listen and somehow, some way, make it different from your group. Make it different from your partner, make it different from everyone. That means putting things in your own words. That means listening and explaining things. And possibly what that means is taking extra notes on the side in a different color where you just explain further. We talked a lot about these two objectives. We're trying to measure, there's two characteristics of sound that you hear. You can say that's loud or soft. You can say that's high volume or low volume. So one of those characteristics is volume. You can also say, oh, that's a really high-pitched sound, or that's a really low-pitched sound. We also have pitch, which would be frequency when you listen to a high-pitched sound or a low-pitched sound. So the two things we're trying to measure are frequency and amplitude. You could say we're trying to measure pitch and loudness. These require the teacher to have checked off on your work. I can check that later. So what you're going to want to do is you're going to want to pull up your data. Okay, so get your data, and you're going to want to look at your graphs. And some of this you can just use logic. So you need to get your Chromebook data. And worst case scenario, you show me later and I mark off, yep, you did in fact get a high pitch, high volume sound. Now we're going to sketch these focusing on the difference. Focusing on the difference. So pay attention to the size of your waves, and size can be measured in two directions. Let me say that again. Look at your waves that you're drawing. Do they look like different sizes? Do they look like different I'm trying to just not give this away, but basically if you look at the different characteristics of a wave that we're drawing, the different characteristics are crest, trough, amplitude, wavelength, equilibrium are the parts of a wave. So when you look at those waves that you're drawing, you want the parts to look different from low pitch to high pitch and from low volume to high volume. So do all those. Make sure they're different. Now you're going to look at your actual graph from the Chromebook. Again, you're going to try to make this yours, and you're going to try to need that data. Here at number 3, you are sketching a y-axis and x-axis. Label the axis. What is it, and what are the units of the axis? And make sure you have the right number of waves in there. Count them. Look at this scale. Look at the times. And here's the hardest part. We're going to calculate the frequency. So remember, for part B, you look at your graph and you're trying to compute the frequency of a high-pitched sound. So I'm going to help you with that. Let's say I looked at this one here. Let me look at this graph. Okay, so if I look at this graph, I want to know what the frequency was of this. 10,000 samples per second. That seems like a frequency, but that's just, this screenshot's just saying that's how quickly the microphone was grabbing samples. 10,000, this sound is going to be much lower. So I'm going to count how many waves I have. This is about one full wave right here. Okay, so I counted how many full waves I had. I had 5 in 0.06 seconds. Sorry, 0.006 seconds. This is very fast. So I can use, here, you gotta listen closely. We did this several times in our notes. I can use the number of cycles that I saw, number of vibrations that I saw, and the time. So what I like to do is get the period first. Think about the period. In my case, 0.006 seems like a time. Yeah, that's a time. So I'm going to take the time and divide it up. That's it. That's the period. Period is the time for one complete oscillation. Period is the time. Time, period. So again, in my case, I'm just going to do time divided by number of cycles. 0.006 divided by 5. That would get me my period. I'll say that again. Think about it. Look at your notes. I did the time and divided by how many cycles there were. That would give me the time for just one. I want to know the time for just one. And counting multiple is much more accurate than just like trying to estimate off this graph. Then frequency is 1 divided by that. Frequency is 1 divided by the period. Okay. So go back and listen to that again if you didn't know, if you didn't understand. You kind of got to know your tuning fork frequency to do this one, part C, because you want to know the actual frequency of your tuning fork is the thing that's stamped on it, which we wrote here, hopefully those numbers. Hopefully we wrote the numbers here for the tuning fork. So you do the experimental as what you experimentally found from your graph here. So you got a number for part B. Let's say it's like, let's say you got like 330 and the actual tuning fork says 320. So I would do 330 minus 320. They say absolute value because let's say you might have gotten something lower and you come up with a negative, we can just drop the negative. So it's 330 minus 320 divided by 320 if 320 was the actual. This is just a percent difference. That's all it is. It's just getting the difference between your 320 and your 330. Like how different are they really? Because you should think of that as a percent. So this will give me my percent error. Usually we're about 80%, or sorry, 95% accurate. Pitch and loudness. Hey, look at your graphs. Just look at your graphs. Pitch, loudness, high pitch or low pitch. What do you see on the graph? Loud or soft? What do you see on the graph? And then there are numbers on your graphs. There are numbers that you counted. Now, number 5, quietness of a sound from far away. Here's my major hint for number 5. A lot of you, when you figured out how to get a loud sound, you realized you needed to bring the tuning fork closer to make a louder sound. If you wanted a really quiet amplitude, a low amplitude, then you could bring it farther away and the sound wave appeared much more quiet, more low-key, lower energy. So it's a very simple answer, number 5, but just make sure you use wave vocabulary. To summarize, go back and listen to this again if you need to. Make sure you're writing things in your words. And good luck.